Welcome to video 2, yes, I think I can count, of our lecture video series for Wednesday, March 22nd, where we are beginning to discuss precipitation reactions. So let's start with a definition of what a precipitation reaction is. So in a precipitation reaction, two solutions of dissolved or what we call soluble salts, which is another way of saying ionic compound, so it's not just specific to table salt, are mixed their ions undergo a double displacement and as a result, a new insoluble solid product is formed. Where insoluble means it cannot be dissolved in water. And what we call this new insoluble solid product is we call this the precipitate. And you can think about where you've heard this word precipitate before, like precipitation, where you have water falling out of the sky. So precipitation in chemistry is talking about a solid falling out of solution. So for example, if we were to look at our general reaction of AB aqueous reacting with CD aqueous, then as a result of the double displacement between our anions B and D, I would have potentially AD and CB products, and one of these may be insoluble in water. In other words, one of these would be a precipitate. So anytime you saw in lab yesterday cloudiness, murkiness, opacity, solids, you were witnessing some kind of precipitation reaction. Okay, so the whole idea is that precipitation reaction, we have our solutions of dissolved soluble salts or dissolved ionic compounds that when mixed and undergo a double displacement, form a new insoluble solid product that falls out of solution, which we call a precipitate. Now, before we get into the solubility rules, meaning how we can predict whether or not a precipitate will form as a result of the mixing of two ionic solutions, is we need to ensure that when we consider any kind of aqueous reaction, specifically for now, at least for us, precipitation reactions, though we'll look at some more, we need to ensure that our products are charge balanced first. meaning we need to make sure that we are creating neutral product compounds. So if we need to ensure that we can make these charge neutral product compounds, be they solids or not, then that means we need to have a very firm grasp of predicting the ionic charge of different elements based on their position on the periodic table, and also knowing the formula and charges of all those polyatomic ions. So polyatomic ions do not go away. In fact, they're going to be very important as we move into our discussions about different types of aqueous reactions, precipitation included. So, how is it that we can identify or know when a precipitate is going to be formed? So, we are going to utilize in our next lecture video something called the solubility rules, which is going to allow us to predict if a particular ionic coupling results in the formation of a solid ionic solute. I guess it's not a solute, solid ionic product, which we call the precipitate. So, up next, the solubility rules.